all viewers, Merry Christmas and a Happy New Year 2022. Please subscribe, much appreciated. Welcome to Lesson 9 of Practical Biostatistics. We have looked at association statistics of correlation. For today's lesson, we'll be looking at linear regression. In correlation, if the two variables are linearly correlated, we can proceed to derive the slope and intercept to describe the relationship between the two variables. Then we obtain an equation for the relationship by using linear regression. For example, y equals bx plus a, where b is the slope and a is the y-axis intercept at x equals 0. So the equation shows the nature and strength of the variables, and with an equation, we can then use it to calculate predicted values. That is, at a particular x, what is the corresponding y? Linear regression assumes a causal relationship where one dependent variable, which we place on the y-axis, is the outcome variable, and this is dependent upon an independent variable which we place on the x-axis, which is fixed or set by the experimenter or is termed predictor variable. So in correlation, the degree of freedom is n minus 2, where n is the total number of sample. But in linear regression, the degree of freedom is n minus 1. One simple way to understand the degree of freedom used is this. You subtract 1 degree of freedom for each variable. So in other words, there are two variables in correlation. That's why you subtract 2. But in regression, only one is a variable. The other is an independent variable or predictor variable that is set by the experimenter. Therefore, the degree of freedom in regression is n minus 1. The most common linear regression is the least squares linear regression model, or ordinary least squares regression, which assumes the independent variable on the x-axis has no error since this is set by the experimenter. So a good example would be a temperature set for a bacterial growth experiment. However, if the independent variable has error, for example, if you are looking at the relationship between chlorophyll A concentration and bacterial abundance with data that you have collected from the field. So we have to use a model 2 regression for this example. So in model 2 regression, if both x-axis and y-axis are of the same unit, we use the major axis regression, also called principal axis regression. Whereas in model 2 regression, when x-axis and y-axis are of different units, we use reduced major axis regression or standard major axis regression. The least squares linear regression model follows the model 1 regression. So now let us carry out regression analysis in Excel and pass. Excel has module for model 1 regression but not for model 2. Therefore, for model 2 regression, we will focus on pass. Please take note that these are for interval and ratio scale data. So this is the set of data that we showed to have correlated earlier. To carry out a linear regression, the column on the left will be placed on as an x-axis, and the column on the right will be for your y-axis. So x and y. So to carry out linear regression, click on data, look for data analysis. look for regression, the menu here, click OK. So Y will be here, and X range will be here. Since we have included the labels, I'll tick the labels here. For output range, I will just place it from here onwards. So this is the summary output for linear regression to show the relationship between chlorophyll A and bacterial abundance. So here you can see the slope, and here you can see the intercept. And this is the F value for the regression analysis with a significance. So this is less than 0.05. That means the linear regression is significant. However, in Excel, this assumes a model 1 regression, but this is probably more suited for model 2 regression. So let's copy the data here. Let's place it in pass. We click column attributes so that we can paste the column label. Then we select all by pressing Ctrl A, and under the menu model, linear, bivariate. So here we see the ordinary least squares method, and you can get the statistics here where the slope and the intercept is here, probability for the linear regression. However, this data follows the model 2 regression, and since they are of different units, we will choose the reduced major axis regression. So you can also look at the statistics here. If the y-axis and x-axis employs the same unit, you can carry out the major axis regression by clicking it here. Then you will be able to get the results here. So this is how you can carry out model 1 regression in Excel, and both model 1 and model 2 regression in PASS. Thank you very much.